Hello students, welcome to the topic definite integration. Today we will continue problem based on properties of definite integral. This is your first question. Integration of 1 upon x plus root of 1 minus x square with respect to dx goes from 0 to 1. So in the solution we will consider the given integral as I, that goes from 0 to 1 upon x plus root of 1 minus x square with respect to dx. Now students, here we have the root of 1 minus x square, which is same as root of a square minus x square. So what is the substitution? X is equal to a sine theta, right? So similarly here we will take x is equal to 1 sine theta. Now instead of 1 we can write it x is equal to sine theta. Let us differentiate. If I'll differentiate, I'll get dx is equal to cos theta d theta. Since we have taken the substitution x is equal to sine theta, now we have to change the limits. So when lower limit x is equal to 0, substitute that, we will get 0 is equal to sine theta. That means theta is equal to sine inverse of 0, and the value of sine inverse of 0 is 0. So we can say that when x is equal to 0, theta is equal to 0. Now let us substitute the upper limit. X is equal to 1. So it will become 1 is equal to sine theta. So theta is equal to sine inverse of 1. And we know the value of sine inverse of 1, that is pi by 2. That means now the limits goes from 0 to pi by 2. And your original integration, earlier it goes from 0 to 1, right? But now here we will write it goes from 0 to pi by 2. Instead of dx, we will write it cos theta d theta upon, instead of x, it is sine theta plus root of 1 minus x square. So we can write it root of 1 minus sine square theta. And we know very well, 1 minus sine square theta, that is cos square theta. So root of cos square theta will become cos theta. So the step becomes this way. Integration goes from 0 to pi by 2 cos theta upon sine theta plus cos theta with respect to d theta. Let us give the expression 1 to that. Now I am applying the property number 4 of definite integration, that is integration of f of x with respect to x goes from 0 to a is equal to integration of f of a minus x with respect to dx, that is upper limit minus x. So here replace theta by upper limit, that is pi by 2 minus theta. So the step will become this way. Integration goes from 0 to pi by 2 cos of pi by 2 minus theta upon sine of pi by 2 minus theta plus cos of pi by 2 minus theta with respect to d theta, right? Now here we'll take the help of allied angles. Since we know cos of pi by 2 minus theta is sine theta and sine of pi by 2 minus theta is cos theta. So I'm substituting that integration I goes from 0 to pi by 2. It becomes sine theta upon cos theta plus sine theta. Let us give the expression 2 to that. Now here I'm adding the expression 1 and 2. Is it your expression 1? That is on the corner. That is cos theta upon sine theta plus cos theta. And here expression 2 sine theta upon cos theta plus sine theta. So look at that. Adding 1 and 2, I'll get on the left hand side 2i. Integration goes from 0 to pi by 2. It is common from both the integral. So taking common integral, that is cos theta plus sine theta upon cos theta plus sine theta with respect to d theta. Now look at that. Numerator and denominator both are same. So both will get cancelled. And the remaining term will be now 1 with respect to d theta, right? So the next step will be 2i is equal to integration of 1 with respect to d theta. That becomes theta goes from 0 to pi by 2. Now by fundamental principle, let us substitute upper limit and lower limit. So it will become 2i is equal to pi by 2 minus 0. So 2i is equal to pi by 2, hence the value of I becomes pi by 4. This is your final answer. Thank you.